the question is, a dart is equally likely to land at any point x1, x2 inside a circular target of unit radius. So unit radius ante the dart is a, what's it called, board is a circle with radius 1, and so they are asking us, what's it called, to find, first point is to find joint cumulative distributive function. Joint cumulative distributive function ante it's a cumulative distributive function with two variables, 2D. Just name it joint, it's nothing, it's the same thing. So let r and theta be the radius and angle of the point x1, x2. It's either something like this or it is something like this. So I guess it is this one is a correct diagram, but I understand better with this diagram. So ఒక point మీద we are throwing a dart. It might fall in an angle, like it won't go straight piercing, it won't go piercing, it'll be in some angle with the board, or else it might go straight also, but it'll still have, if it goes straight it is 90-degree. If it lands, the dart lands somewhat like this is the needle and this is 45 degrees, something like that. So they are asking to find the probability that the dart lies within the dartboard, which is a circle of unit radius 1. So first of all, probability formula is total probability, total cases by favorable cases kada. So for it to land on the x1, x2, first of all, total cases, it can land anywhere in the dartboard. It can land anywhere in the dartboard, which means it can land anywhere in the area of pi r square. Here we know r is unit, so r is equals to 1. So total cases lo our value will come as pi. So p is equals to favorable cases by pi. Now here what's it called, favorable cases ki I don't understand this diagram, how to use it, so I understood it through this diagram. So for a thing to land in a sector, what's it called, so you can use this also as reference, like dart, this is the dart and it's making this much angle with the board. So suppose this is a sector, you can see this is a sector. Sector has an area formula, which is nothing but what's it called, theta divided by 2 pi into pi r square. This will give a circle lo, suppose there is a sector this with some theta, it will give the area of this part of the circle, which is a sector. So favorable cases will be nothing but theta by 2 pi into pi r square. The probability of r less than equals to r comma theta less than equals to theta will be nothing but theta divided by 2 pi into pi r square by favorable is pi, which will be nothing but theta less than equals to theta. So pi square and pi gets cancelled, theta r square by 2 pi. So this is our first bit, and the second bit is find the marginal cumulative distributive function. So marginal cumulative is nothing but, suppose marginal, what do we do, suppose there are two terms x and y. For marginal, what we do is suppose marginal of x, what do? We take x to be constant and we keep on changing the values of y. So how does it work? Suppose y values goes from 0, 1 and 2. So it will be nothing but probability of x comma y equals to 1 plus probability of x comma y equals to 2 plus probability of x comma y equals to 3. As you can see in first and second question, it is suppose x value they will give something 1 and they will tell the or else they will tell x equals to 1 low marginal probability distributive function, marginal cumulative distributive function enta ani adugute, we'll just change the values of y, but we will keep the x value as constant. So it will be something like 0 plus p of x equals to 1 comma y equals to 1, and so on. Same, x value will be constant. So here, so what do we understand by this is, when we add up all these stuff, it will lead the y value to its maximum point. Suppose we add 0, then we add 1, then we go on, so we will get until the maximum point. That is how marginal works. I don't know if you guys understood that, but you'll understand with the question. So marginal of CDF of r and theta. R and theta won't be together, r and theta. So first of all, we need to write down this formula. This formula is really important, which we got through first question. Theta by r square into 2 pi. So first we're gonna find marginal of r. So if we are finding marginal of r, what do we keep constant? We keep r as constant. And what do we keep on changing? Theta. When theta keeps on changing, it will go 0, then it will go some value, some value, some value. Its max value is 2 pi in a circle. I mean, anywhere it will be 2 pi. It will go from 0, it will go around, it will become 2 pi. So we will directly substitute what's it called, theta value as 2 pi. So it will be nothing but 2 pi r square by 2 pi, which is nothing but r square. So this is marginal cumulative distributive function with respect to r. And for theta, it will be nothing but same thing. Here, what's it called, the maximum value of r will go to 1, because they set the unit radius circle. The circular board, maximum it can go to 1. Theta will be constant, so it will be nothing but theta by 2 pi into 1 square, which is nothing but theta by 2 pi. And now C part. C part is a unique part, because here the question is, use the joint CDF to find the probability that the point is in the first quadrant. First quadrant ante angle will be between 0 to pi by 2. Okay, so theta is lying between 0 to pi by 2. And then what is it called, r is in the first quadrant of the real plane, and that the radius is greater than 0.5. So radius should be greater than 0.5, and maximum is 1 because it's a unit radius board. Yeah, so now we have to find the probability joint CDF, but normally there is only a single condition. Here there are multiple conditions, like it should lie between this part and this should lie between this part. So this has a specific formula which can be written like, or which can be derived, because I'll derive it so you guys can understand it and no need to buttify. See, so first of all, a coordinate system తీసుకున్నాం. This is the least value of theta, this is the least value of r. So least values will be, suppose ఇది some x, ఇది some y, అంటే in the case of this question something is theta, something is r. So let's take this point to be 0, 0.5. So what will this point become? Max values rendu, because it is in the highest place kada, pi by 2, 1. And what will this point become? What is it called? Mana r is getting maxed out here, ida 1. So let's take this as r and this is theta. You can skip the derivation, but you will understand very clearly after the derivation. So this coordinate will be nothing but r will be maximum, but our theta is minimum, which is 0. So 0, 1. And this is what mana theta max aitundi, and r is minimum only, because here r is 0.5. So theta max aitundi, so pi by 2, 0.5. Now what is the question is, we need to find, so this is our coordinate system, manki e probability find cheyala. So there is a formula to do that. First of all, what do we take? We take the entire dabba. After we take the entire dabba, we will remove this part. Then we remove this part. So what happened? This the only thing which is remaining is this. This is remaining. But what happened while removing two times? One time it tisnam, second time it tisnam. This thing, this box, got removed twice. So we just add this part. So this darker blue nunchi oka lighter shade of blue ki maripotadi. So everything has been removed. This box and this box is only been removed once. So what is the formula is probability of pi by 2 comma 1, which means this entire box, minus probability of pi by 2 comma 0.5. So I removed this box once, minus probability of 0 comma 1, which means I removed this box once, plus probability of 0 comma 0.5. Now I added this box because it was getting removed twice. So this is our formula. So nothing but even manki probability the joint CDF ki formula we had something which is nothing but theta r square by 2 pi through the first question. So now theta inka r value substitute cheseste manki p of pi by 2 comma 1 p of pi by 2 comma 1 is nothing but pi by 2 1 by 2 pi. It is 1 by 4. This is pi by 2 comma 1 by 2. This is nothing but pi by 2 1 by 2 2 pi cancel 1 by 8. 1 by 8 ఇది r square kada. So 1 by 2 square. So it will become nothing but 1 by 16. Then what do we find? P of 0 comma 1. Remember we used in the form of theta comma r. So like that I'm substituting. So theta is nothing but 0 into anything will be 0 only. So P of 0 comma 0.5. Did I write the coordinates correct? 0 pi yeah, I guess I wrote the coordinates correct. P of 0 comma this also will become 0 because 0 into anything will be 0. So what is remaining? So this term became 0, this term became 0, and now only this part is remaining. So for this part is P of pi by 2 comma 1 minus P of pi by 2 comma 1 by 2. Which is nothing but 1 by 4 minus 1 by 16. LCM these 4 minus 1 by 16. So our final probability will be nothing but 3 by 16. That's it.